Hello, hello, National 5 chemists. I hope we're all doing really well and ready to continue on with some Unit 3. Today we're going to be looking at reactions of metals, and there's three different reactions that we need to know. Now, those three reactions are when, first of all, we take a metal and we react it with oxygen gas. The second reaction of metals that we need to know is when we take a metal and we react it with some water. And then the third reactions of metals that we need to know is when we take a metal and react it with an acid. Now for each of these three reactions, we need to know the product or products formed in this reaction. So let's go back up to the first one. I've got a metal reacting it with some oxygen gas, and I'm going to produce a metal oxide. So depending upon what metal I use, whether it's copper or magnesium, will depend upon the metal oxide produced. So for example, if I used copper, reacted it with oxygen, I would produce copper oxide. But the general statement is when we react a metal with oxygen, I produce a metal oxide. Next one, we have got a metal and water, and here we will produce a metal hydroxide plus hydrogen gas. So two products in this reaction. If I take a metal, place it in water, I'll produce a metal hydroxide and hydrogen gas. Now you may remember from Unit 1 that a metal hydroxide is an example of a chemical called an alkali. So if I take an alkali metal, something from group number 1, place it in water, I'll produce an alkali, or known as a metal hydroxide and hydrogen gas. So there's our second reaction. And the third reaction that we need to appreciate is if I take a metal, react it with acid, I'll produce a metal salt and again hydrogen gas. So those are our three different reactions of metals that we need to know. We'll take time now to look at an example of each one, write out a word equation, then an ionic equation, and talk a little bit more about which types of metals will react with either oxygen, water, or acid, because they don't all react with each different chemical. Only certain only certain metals will react with acids, only certain metals will react with water, and again, only certain ones will react with oxygen. Right, let's look at this first reaction in a little bit more detail now and look at a specific example. So I've got a metal, I react it with oxygen, and I'll produce a metal oxide. Let's say my metal that we're going to use is magnesium. So I'm going to take magnesium, I'm going to burn it or react it in oxygen. I'll produce the metal oxide, magnesium oxide. Nice and straightforward there, that makes sense. If I take magnesium, react it with oxygen, I will produce magnesium oxide. There's the word equation for that reaction. The Ionic equation is something that will be very useful for us throughout this topic, looking at the change that's happened in these metals in terms of their electrons. And we've not talked about it yet in this series, but we will talk about it in a lot more detail, looking at how these metals have changed, become ions, and that's important to discover whether they've been oxidized or reduced, but that's going to be for a later date. What we want to worry about now is writing down an ionic equation. Ionic equation is very similar to our chemical equation, except when I've got ionic bonding, I'll also put in the charges as well within the ions. So let's look at our first chemical here. I've got magnesium. Symbol for magnesium is Mg. Plus oxygen. Oxygen symbol is O. It's diatomic when it's by itself, so it's O2. And then magnesium oxide. Well, I've got the name of a compound here. I'm going to go through my little steps. S, V, S, D, and F. to get the correct chemical formula for magnesium oxide. Symbol, valency, swap, divide, and then formula. So magnesium is Mg, oxygen is O. Magnesium's in group number 2, so it's got a valency of 2. Magnesium's in group 6, it's got a valency of 2 as well. Swap them round, and I can simplify this down because I've got a common factor of 2, and therefore the final formula for magnesium oxide, I've got 1 Mg and 1 O, so it's just MgO. Now there's my chemical equation, but I've been asked to write down the ionic equation, and I put in charges where relevant, and that's very important because I only put charges in for ions or when I've got ionic bonding. Now, if we remember again back to Unit 1, ionic bonding is when I have bonded together a metal and a non-metal. Magnesium does not exhibit ionic bonding. It has metallic bonding, so I don't need to put in any charges here. Oxygen is a covalent molecule, a non-metal bonded to another non-metal, no ions, no charges. Come to magnesium oxide though, I've got a metal bonded to a non-metal. Well, I need to put the charges in here for the ionic formula. Now, since magnesium's a metal, it always forms a positive charge because metals always form positive charges. They always lose electrons to form ions. It's in group number 2, as we've talked about before. So its valency and the charge are going to be the exact same. Magnesium ion has a charge of 2 plus. Oxygen's a non-metal, so that's going to be negative. It has a valency of 2, so the oxide ion is 2 negative. Now a quick wee way to check if I've done the ionic formula correct is if I add up these charges, 2 plus and 2 negative comes out to be 0. That's a nice wee way to check it. If it doesn't come out to be 0, I've probably done it wrong. And there's my ionic equation for magnesium, oxygen, reacting together to form magnesium oxide, our first of these 3 reactions. Now I'm just going to take the time very quickly to go over something that we're going to start to appreciate quite soon, which is what is happening to the magnesium as it changes from a reactant into a product. So over here, we've already established that magnesium has metallic bonding and there's no charges associated here. So effectively it has a charge of 0, it's neutral. If I compare magnesium on the left hand side to magnesium on the right hand side, the magnesium has now become, on the right hand side that is, the 2 plus ion. So what's happened to that magnesium to become the 2 plus ion? It has lost 2 electrons. It has lost 2 electrons. Now in chemistry, we call the loss of electrons, if something loses electrons, that is an oxidation reaction. So the magnesium has been oxidized or has undergone an oxidation reaction to form the Mg2 plus ion. Okay, now let's look at our second reaction of metals. We've looked at a metal plus oxygen to give us metal oxide. Now we're looking at a metal plus water, and that forms a metal hydroxide and hydrogen gas. Let's take the metal, sodium. Let's do sodium. I'm going to react that with water, and I will produce the metal hydroxide, sodium hydroxide, and I will also produce hydrogen gas. Now let's look at writing the ionic equation here. Sodium's chemical formula is Na. Water is H2O. Sodium hydroxide, probably going to just take the time now to do S, V, S, D and F for that. I know sodium is Na. Hydroxide is one of those complex ions that you'd find on page 8 of the data booklet, and its chemical symbol, or formula rather, is OH. Sodium's in group 1, so its valency is 1. Hydroxide has a charge of -1, so its valency is always the same as the charge. Charge of 1 negative, its valency is 1. and swap them round, divide through, it's 1 and 1, so the chemical formula for sodium hydroxide is NaOH. And let's not forget, I also produce hydrogen gas in this reaction as well. So, I want to write in the Ionic equation, which means I put in charges on ions where relevant, or where they have ionic bonding. Sodium is a metal not bonded to a non-metal, so it's just got metallic bonding, no charges. Water is a covalent molecule, two non-metals joined together, no charges. Sodium hydroxide, sodium's a metal, oxygen's a non-metal, hydrogen's a non-metal. Okay, we have got ionic bonding here. Sodium, as I said, is a metal. Metals always produce positive ions by losing electrons. It's in group number 1, so it gets the charge of 1 positive. The hydroxide, OH, has an overall charge of 1 negative, and we can find that on page 8 of the data booklet. Hydrogen gas, well, again, that's a covalent molecule. There's no ionic bonding, so there'll be no charges there associated with this. And then let's just look through, is this equation balanced? I've got 1 Na here, 1 there, 2 hydrogens here, and 3 hydrogens on this side. So let's put a half in next to that H2, just to make sure we've balanced our equation as well. So a metal plus water produces a metal hydroxide and hydrogen gas. Let's not forget though that that metal hydroxide is an alkali. And as I mentioned at the start of the video, not all metals can react with water. We'll know this already. If you think about copper or any other kind of common metals that you might have, they don't really react with the water. Normally, we're thinking metals that belong to group number 1 in the periodic table and group number 2 in the periodic table. They will react with water. Group number 1, alkali metals, named so because when I react them with water, I produce an alkali. Group number 2, the alkaline earth metals, again, similar idea. I react them with water, I'm going to produce an alkali. And let's look at our last example now, or our last reaction. We've got a metal plus an acid produces a salt and hydrogen gas. So let's take another example here. What can we use this time? Oh, let's do calcium. So if I take calcium and react it with an acid, let's just choose hydrochloric acid. Oh, I'm writing the word equation. Hydrochloric acid. I will produce the metal salt. So the salt's going to start with the name of the metal, calcium, and it's going to end with the type of acid I've used here. So I've used hydrochloric acid with chlorine in it, so I'm going to produce calcium chloride, the chlorine coming from the hydrochloric acid, and hydrogen gas as well. Right, now let's look at the ionic equation here. Calcium is Ca, hydrochloric acid is HCl, and that is producing calcium chloride. So again, I'm going to want to do SVSTF here to figure this one out. Calcium is Ca, chlorine is Cl. Calcium's in group 2, valency is 2. Chlorine's in group 7, so its valency is 1. Swap round. No common factors other than 1, so it just stays the same. And I've got 1 calcium, Ca, and 2 chlorines, Cl2. Okay, so pop that into our equation. Ca, Cl2 plus hydrogen gas diatomic, H2. Ionic, got to put the charges in now. Calcium is a metal, metallic bonding, no charges to put in. Acids, we should remember from our unit 1 that they do carry a charge. We have got the H plus ion and the corresponding Cl negative ion. The hydrogen's behaving like a metal here. It loses its electrons to the chlorine, becomes positive, and the chlorine becomes negative. Over on this side, I've got a metal calcium and a non-metal chlorine. Calcium is in group 2, so its charge is 2 plus because it's a metal. Chlorine, well, each chlorine has a charge of 1 negative, and there's 2 of them, so that would give me a total of 2 negative, which would cancel out the 2 positive. So my ionic formula, Ca2 plus, Cl 1 negative, 2, and that's also producing hydrogen in this reaction. And then I'll just put another, well, let's balance this. I need a 2 here to balance it. And there we are. We have looked at all 3 different types of reactions with metals now. Metal and oxygen, metal and water, and a metal and an acid. You need to know what they produce and be able to write out something like that ionic equation. Now, at the back of your data booklet on page number 12, you will have a page that is not too dissimilar to this picture here, where we have got something called a reactivity series of metals. It's basically like a kind of league table of the metals, with the most reactive ones at the top and the least reactive ones at the bottom, which is very useful for us because we need to be able to appreciate which metals will react with oxygen, which ones will react with acids, and which one will react with water. And so we can look at this kind of league table and think to ourselves, well, the most reactive ones at the top, they're probably going to react with water, acid, and oxygen. And they do. The ones in the middle aren't as reactive as the ones at the top, so they may be only going to react with a couple of things, and they will only react with acids and oxygen. And the ones near the bottom will only react with oxygen, and the ones right at the very bottom, like gold and silver, just don't really react at all. So there's got this kind of league table of reactivity. Now, I would write on my data booklet this information just at the side on page 12. Just put a wee line in between magnesium and aluminium and an arrow going up at the side and saying these metals react with water to produce a metal hydroxide and hydrogen. And then I would put a little line just above copper in the table and say the same thing, but this time with acids, say these metals all the way up from above copper react with acids to produce a salt and hydrogen. And then again, I would put one more little line just maybe above silver and say, well, all these metals react with oxygen to produce metal oxide. So we need to know which ones react with what and what they produce.